Okay. You can see, right?
Yeah, I can see.
Okay. Okay. Yeah. Uh, Good evening, all. My name is Pravardhan. Today we are starting MongoDB Module 1 session. We are actually a partners of RS Trainings. We are from NXGClasses. If you have any doubts or queries, you can mail us at support@nxgclasses.in, or you can call us at our number 837479394. Okay? And today is the first day session. We'll see our agenda will cover the topics like what is big data and how to address big data and MongoDB features and what MongoDB is not. I mean, like what areas we usually don't recommend for MongoDB, and where all the companies right now MongoDB in production is in usage, and we'll also see MongoDB terminology comparison with regular relational databases like Oracle or MySQL database kind of thing, and JSON introduction. JSON documents are very important in the MongoDB course. So we'll just have an overview like what exactly is a JSON document and how it looks like and how to write a JSON, and all those things we'll see. And also we'll see data types in MongoDB. Okay, these topics will be covered in today's session. So yes, the first thing which comes into our mind is what is big data. This big data is very tightly coupled with MongoDB technology, because it is also a big data database. MongoDB is also known as a big data database. So before talking about MongoDB, it actually makes sense if we talk about what is big data. A big data is nothing but, it's not a technology, it's a scenario where each and every company or organization at one point of time will undergo this situation. It's a normal data which will have the characteristics like it will be very high volume with a very high velocity and different varieties of information assets will be coming in. So we need some new forms of processing to enable enhanced decision making, insight discovery, and process optimization. I mean, it's a scenario where, as I said, like the big data will have three kinds of characteristics: so volume, velocity, and variety. The amount of data coming in will be very huge. It will be in terms of terabytes or petabytes, even per day, or you can expect very high amount of volume even in a very less span of time, like almost covering 1 terabyte of data per day. That kind of huge volume will get, and with a very high velocity. One day itself we are getting a 1 terabyte means that's very high velocity, which means the number of write requests coming into the database will obviously be more, because that many number of requests are coming in. We need to write everything into database, and a high variety of information assets means different forms of data will be coming in, and all the data we need to handle in a very optimized way. So any data problem which will have all these characteristics, we will consider that as a big data scenario. Okay. So I'll give a small example of what big data problem. Okay. Let us take an example of a Boeing aeroplane, okay, which will have a millions of sensors in it. The running flight will need to log all the information. I mean, like each and every million sensors, whatever it has, each and every sensor needs to capture its log information into some database, because That information will be used for further processing and for decision making. They'll check the quality of which sensors are working properly and which are not working properly. In order to make such kind of decisions, that logging is very important. So in that case, if million sensors are there, and since the flight will be running for 24 hours or 48 hours at a stretch, it will run. So you can imagine how much amount of data will be coming from each and every sensor. If it is that will be like terabytes of data will be coming, even if a flight runs just for one day or a half a day also, we'll get so much amount of data. And this tells what the volume is and velocity. Okay, and what about the variety? Say for example, each and every sensor will have its own attributes. For example, if there is a sensor for AC in the flight, and it will have its own attributes. And say for example, if there is another sensor for engine, how it is working and all those things, let us assume. So it will have its own properties. Like that, that million sensor, whatever it in the flight is available, each and every sensor will have its own attributes. Say, as a developer, if someone asks you, or a database administrator, you ask to create, each and separate tables for each and every color, every sensor, it's not practically not possible to create a million tables for each and every sensor to handle. You got it right?
Got it. Can you just hold on for just a moment?
Yeah.
Okay. Yeah. You can tell me. Proceed.
Can I continue?
Yeah, please. Yeah, you can. Okay. She called me actually. I don't know what's the problem. She sorted out. She got disconnected again.
Okay. Okay, no problem. I'll be sharing anyhow the links so that you can hear it offline. Okay, so you got it right. I mean, like the variety means different. Each and every sensor will have its own attributes. Say, for example, if we need to capture million sensors data, it's not possible. It's not practically possible to create a million tables. Okay. So that's one problem of the big data. Okay. Then comes like how to address this big data problem. There are actually two ways of handling a big data problems. That is one by vertical scaling. The other one is by horizontal scaling. First, what is the vertical scaling? Vertical scaling means in this case, what we will do is we will buy a very costly servers like blade servers or very highly powerful servers which will have a large amount of CPU capacity and RAM. We can have, yes.
Hello?
Yeah, she was able to figure it out?
No, she is not able to figure it out. She said that you guys carry on with that, and later I will get the
Yeah, sure. I'll send a recording, not a problem. Okay.
Yeah, we were into vertical scaling.
Yes, vertical scaling means we need to add more number of CPU and RAM to a very costly server, which will also have, this is a powerful servers we have in the backend. But even if by having these kind of servers, there will be again a limitation, at some point of time, even how costly, whatever the costly machine you use, how much of the RAM you have, there will be again a limitation. You can't have GBs or terabytes of RAM or or even in the space also there is a limitation. You can't have like whatever the amount of space you need on single machine. So that won't address the big data problem properly. So what is the other alternative is we can go for horizontal scaling. So what is horizontal scaling? Horizontal scaling is you'll be adding more number of machines into a cluster, which is nothing but a distributed environment. I mean, like we'll take a normal commodity servers like normal physical boxes, like which is having like 64-bit Linux with Red Hat Enterprise OS, or Ubuntu normal servers, like, and which will have a like 4 GB or 4 GB of RAM and with 1 TB of hard disk. We'll take these kind of cheap servers and we will combine say hundreds or thousands of machines into one cluster, which is nothing but a distributed computing environment, and we will use these kind of systems to address the problem. Here what happens is we need to deal with, in the case of big data, we need to address two main things. One is the amount of storage. We need large amount of storage. So for that, what we will do is each and every server will have its own hard disk space. Say for example, if each machine is having 1 TB, if we combine 100 machines, we will get 100 TB of hard disk space. Though it is in different machines, then logically it appears like a single hard disk which is having 100 TB of space. Okay. And similarly, the computation also, how it happens in distributed environment is each and every machine will, in its own CPU, it will run on the result set available in its hard disk. That means, say for example, a machine A, if it has its own data in the hard disk, it will work on the data which is available in its hard disk. Similarly, all the machines will work, and finally it will be combined, the result set, and will be sent back to the client. Like that, the CPU problem and hard disk problem we can address easily in the case of distributed environment.
Okay, you say that this can be related to tuning part in Oracle. Is that a kind of a tuning?
No, this is not tuning. I mean, like, this is like a kind of architecture in order to address the big data problems. Like, say for example, what are the what I said is a concept. Horizontal scaling means combining multiple machines into single cluster. So the cluster itself logically appears like single machine. Logically it appears as a single machine, though it is a combination of multiple systems. You're getting right? So whenever we are running out of hard disk space, we will add more number of clusters, more number of machines to the cluster.
Okay.
So that we will get more space and more CPU on fly. Whenever there is a demand, we will add more number of machines. Okay? Now you got it, right?
Yeah,
so that we will never run out of hard disk space and we will never run out of CPU usage. We will be always, whenever we are running out of load, we are getting more load, we can add more number of systems, and when we are running out of hard disk space, we can add more number of machines to a distributed cluster. Okay, this is a concept. Okay, then comes what is the technology which in realization of this, which is the implementation of this horizontal scaling. What are the technologies available? Currently, there are many technologies, out of which very popular one is Hadoop, and the other thing is big data database MongoDB. In case of
Hadoop, right?
Yes, big data is not Hadoop. Big data is a scenario.
Okay.
As I said earlier, it's a problem where we'll need to deal with large amount of data.
Okay.
Hadoop is one kind of technology or a platform which enables you to solve that problem. We can go for Hadoop. For addressing big data problems, we can go for either Hadoop, or similarly like that, we can also go for MongoDB. Okay, now you got it, right?
Yeah.
Okay. So one kind of technology is a Hadoop. In since Hadoop is not part of our course, we won't deal with it much. I'll just give an overview how Hadoop works. And in the case of Hadoop, what happens is there will be multiple machines. In each and every machine, we will be installing Hadoop software so that one among the nodes will, among the multiple nodes, node in the sense machines, will act as a master and the remaining nodes will be as slaves. Okay? The master node will have information about all the nodes in the slaves, all the slave nodes, so that this acts like a metadata point where what kind of information is available with which database, I mean which machine.
No, not clear. I mean,
Not
is
clear.
it the same screenshot, or I mean, do we have to change the screenshot for that for this?
No, we don't have any slide for Hadoop because that's not part of our course, right? I'm just explaining it.
Okay.
Okay. Okay, don't worry about Hadoop thing.
About Hadoop, yeah. Please.
Yeah, okay. Let us leave that. Okay.
Yeah.
So for addressing, you should understand about horizontal scaling. That's very important.
Okay.
Horizontal scaling is more number of machines we will combine into one one cluster, and that will be used for addressing the problems.
Okay.
Got it?
Okay.
Then MongoDB will see. So MongoDB is also one of the technology which can be, or a database which can be used for addressing big data problems. Okay?
Okay.
Okay. What is MongoDB? A MongoDB is an open source document based database. It's completely written in C++, and it was developed by a company which is initially called Tengen. Now it is known as it was again renamed as, the company name itself as MongoDB Incorporation. Okay, and what are the features available for MongoDB? Okay, it's a document oriented storage. MongoDB stores each and every record as a document inside its database. The storage wise, it stores everything as a document. What the document is of type is, it's a JSON document. We'll come to know what JSON document and how it looks like. As of now, we just think that MongoDB stores everything, each and every record in a MongoDB is a JSON document. Okay. Next is, MongoDB is a schema-less database. Schema means metadata. Whenever you want, for example, in Oracle database, if you want to create a table, you need to specify its, you need to write its schema first. That means you have to tell like what are all the columns available in that, and you need to specify what is the data type and what is the size limitation. You have to specify primary key constraints, you can specify unique constraints. All these things you need to specify if you need to write a table in Oracle or any other relational database table. But when it comes to MongoDB, it is a schema-less database, which means you don't have to create any schema for MongoDB. Got it?
Yeah.
Because there are no constraints on data here. Whatever the data comes to a MongoDB, it can capture it without any restrictions. Okay? That means, for example, if I have to tell, you don't have to create any table here. The moment you start inserting into it collection, here collection is nothing but, in MongoDB terminology, a collection is nothing but a table. Okay? So, the first time if you try to insert a record, it will automatically create a collection and inserts the document into it. say for example, it makes more sense when I explain you about the JSON document. Okay, as of now you just think that we don't need to have any schema in the case of MongoDB. Okay? It won't have any restrictions like unique key constraint like that. You don't have any constraints also. And index support, full index support will be available. Like the index support is available in Oracle and other databases. We also have index support here. Okay, we can create indexing on all the keys. Okay, we will come to know what is keys and what is a document, what is a collection in the terminology part. Okay, and replication. What is replication? Replication means a high availability. You know, for the purpose of achieving high availability of the application, we need to implement MongoDB's replication. Okay. For example, if I have to tell what replication is, in MongoDB, we'll combine 2-3 nodes, node in the sense Mongo instances we will combine into a replica set. Okay, each and every one among the replica set will be a master, and the others will be slaves. Okay, the master node here in the MongoDB is called primary node. The others will be secondary nodes. Okay. Each and every time the primary will be receiving the reads and writes from the application, and it automatically will be moved to the secondary servers. Okay.
But there is no detailed description for this one actually.
No, you'll come to know when we go for actual replication concept. Okay, these are just this slide. Intention is just covering the features available here. We are not going in detail. Okay.
Okay.
Okay, don't worry about that.
These are the contents actually, right?
Yeah, these are the actual features of MongoDB. We'll be dealing in detail each and every one over the course. Okay.
Okay.
Just wait. I'll show you.
So normally, how many database administrator will be there for MongoDB?
It depends. Usually, only one person will be there.
Only one now?
Yes.
Okay. Will he be able to tackle because it's being a new database?
Yes.
If he has got any issues or problems, like will he be able to solve it single-handedly?
See how the big data, these applications will be, in the production. Usually, it starts with a single replica set. Okay, the replica set means it will have 3 nodes or 4 nodes. It will have or 5 nodes. It will have, and once the data keeps growing, they'll add more number of machines, MongoDB instances into that replica set. Okay.
Okay. So my question is like,
that's what I'm telling. I got it. What your question? How many number of database administration?
Yeah.
See, that depends. Like whatever the project which I was involved, we used to have only one database administrator in on-site and one few MongoDB developers kind of persons will be there in the offshore, which will be, see, this is actually MongoDB is very user friendly, and you don't have to, it reduces a lot of database administration effort. Okay. For example, if I have to give an example, say in case of Oracle, I was not able to get the diagrams.
Now, how can you compare this actually to this Mongo database to which you can compare?
And
database, DB2, SQL.
no, they are completely all those databases which you have, which you are telling is they are normal relational databases. All of them are similar.
Okay.
But what MongoDB is completely different from them. It's like, for example, see, the number of write operations you can do on a regular relational database table is, it will be in thousands per second, the number of concurrent transactions. Okay, but in the case of MongoDB, and this is like transaction, it's not transactional based database. I mean, like here, it won't have any transactions. You can right away write a database record without, hello? Vijay, is there? Vijay, is there? Hello. Vijay, you there?
Hello? Yeah.
Yeah, Vijay. Yeah, what happened?
Actually, someone called me. There is nobody in house actually.
Yeah, okay, no problem. Okay, no problem. Yes. Check. Okay, we are in the replication, right? See, replication means first let me start the recording. I just paused it. Okay. It's okay. We are dealing with we're explaining what is replication. See, first let me explain you what all the features are available. Over a period of time, you'll get what exactly it is and what is the difference from between the relational databases as well as MongoDB. Okay, replication means, just think, it's very simple. For the purpose of high availability, we will have a replication. In what exactly replication is? We'll combine three or five Mongo instances in the sense Mongo servers, into a replica set. One among the replica set will be a primary node, a primary Mongo instance, which will receive all the incoming reads and as well as outgoing write. I mean incoming write operations as well as outgoing read operations. It will be handling. All of a sudden, say, let us assume a power failure or due to some crash, that server went down, that primary. In the case of regular relational database, what happens? How you will be handling this situation, may I know?
Yeah, relational. I mean, if there is a replication, it automatically then other secondary server.
Yeah, your voice very low.
In case of this Sybase and all,
Yes.
the other server, the secondary server shoots up automatically. And
Automatically.
There is an option like you have to manually also you all to make it up actually.
Yes, that usually mostly it will be manually you will be doing, because I'll tell you what happens. In the normal regular cases, what happens is whenever the failure happens, the database administrator needs to switch the secondary, or he needs to change the IP address so that it start pointing to the standby server. Which but in the case of replication set in MongoDB, what happens is if the primary goes down, automatically a polling happens among the rest of the secondary nodes, and it will decide who will be the next primary. Okay, everything happens in the fraction of seconds, milliseconds, and one among them will automatically becomes the primary, and the application layer will never come to know that some node has gone down. Okay, this is the advantage of replication set in MongoDB. Okay, which is not available in other databases. Okay, you got it? You'll come to know more about replication when we are dealing with it. Okay, as of now, you just think that replication means it takes care of availability. It means for the application layer, it can feel comfort that database will never go down, because the switching happens automatically, and always there will be one primary available. Okay. And moreover, what we will do is during setting up replication, we'll plan such a way that one or two nodes, say for example 3 nodes if we are having, 2 nodes will be in one data center and 1 will be in the other data center, so that failure of all nodes will never happen at any single time. All failures won't happen. You got it? Okay. Okay. Next concept is auto sharding. This is called.
One clarification. Actually,
yes.
When you are recruited for one MongoDB administrator.
Okay. Yes.
I mean, will there be? I mean, you guys are responsible for setting up all this replication and configuring and all those things, or it will be already there will be a setup.
See, that depends. So whenever we started almost in the year 2012 end, 2013 beginning we started. That was the time we got MongoDB, and no one knows nothing about the MongoDB. It's a complete new technology. What we did is it's a complete from the scratch we developed. We explored the features. We were in talks with Tengen, which is the vendor at that time for MongoDB, and we took the support from MongoDB team, and they helped us, and they told us what exactly it is, what is the difference between compared to the relational databases, and we set up replication. We took.
You took the support from MongoDB team, right?
Yes.
What is the team actually? What is the team actually? And is that a customer care kind of?
Yes. Right now, yeah, there will be a support. The moment you install MongoDB, there is a registration process. You can also go through. That team will automatically send follow-up emails. I don't know now how they are doing. Initially, whenever we set up a MongoDB, it will ask for an email. If you provide, there will be automatically one person will be addressing you, will be talking to you. If you need any kind of assistance, they'll be providing. Since now it has evolved a lot, and that kind of one-on-one support won't be available at this point of time, because that time it's a new database, they want to promote more, they're giving extensive support. Now if you want a support, I mean like extensive support for any organization, you need to go for enterprise edition of MongoDB. Okay, so with that you'll get customer support, I mean technical support, whatever you need, you'll be provided with. Okay.
Okay.
Otherwise,
One more question.
yes,
See, normally what we do is like what this once we get a project, what this OS guy like Linux or AX or Unix or Solaris, what
correct.
they do is they give. I mean, after their activity, they give the space. I mean, they give it after activity is completed. They give it to us, and then what we do is we create the database and we set up the installation for the database, and then we create the database and we allocate the size and all. Like okay, so similar way, what would be the OS here, and what would be your activity?
Yes. Anywhere, wherever you go, the production first operations team will install all the OS and you'll be getting it to the next database team. Once you get the database team, this is not installation part. I mean, you can get a copy paste version, like a zip version you can get, you can get a tar version where you can unzip it and there will be daemons available. You can make them straight away up. Okay, it hardly takes like altogether 300 MB space for the binary itself, and the software itself will be that much space. And usually in production, it's recommended 64-bit operating systems and mostly Linux. You have to install it on Linux 64-bit machines with at least a 4 GB of RAM, and there is no limitation of RAM as well. If it is usually in production, that is minimum 4 GB or 8 GB will be you will be getting, and if you have hardly like 1 terabyte of hard disk on that machine, that's enough for a single instance. Okay. See, for example, if your project is a newly starting application, and usually how it starts is they'll have at least three nodes in the sense they'll have 3 physical servers. They'll install a Mongo. They'll make Mongo servers up on each and every box, 3 boxes, and on top of that they'll create a replications. Okay. Once that,
I mean, after they hand over the server to you, what you guys do is they will give you 3 servers, right? 3 servers they give you.
Yeah, at least minimum 3 we need. Minimum 3 in the sense you can have single server as well. But for replication setup, it is recommended at least having 3 machines. What happens in these 3 machines is it will have same identical data. Whatever the data available in server 1 will be also available in server 2 as well as the server 3. But if server 1 goes down, automatically one among the server 2 or 3 will be chosen for the standard. That becomes the next primary. And this, how it becomes primary and all will happen by the help of replication setup. It will keep polling. I mean, like the heartbeats.
DBA will decide like which one is primary and which 2 are secondary. Correct?
No, initially you will be deciding which one is the primary. But whenever a failure happens, the system itself will decide who can become the next primary.
Okay. Oh, okay.
Okay. So application will never come to know that the database has gone down. Got it?
Okay. Got it. Yeah. Okay. See, then later on, what you guys do is you do the installation part, correct?
Correct.
Okay, installation part is like for 3 servers you do the installation, correct?
Yes, we have to do, and then on top of them, combining 3, we need to set up a replication. That is the configuration stuff.
Okay.
Okay. Those things will be coming in. I mean, we'll see. Okay. Got it, right?
Yeah, got it.
Yeah, at the end of the course, you will come to know what is installation, how to set up a replication, what kind of, how to run those configurations. Like setting up the replication is something that you need to configure, right? You have three different machines. On three different machines, you'll install MongoDB. Combining those three, you need to use some commands and you need to set a replication. Okay, and you can also give priorities for them among them. All those things will come into going forward. Okay, this is just
that's what my question is like. I want to know the contents. For example, installation, okay, then configuration, then setting up a replication, then obviously creating a database, then taking a backup. Okay.
Here creating database you won't be doing. Okay.
Okay. Why?
Okay. Database automatically creates by the application.
Okay.
Okay. The application, when you start writing the data into a database, if it is not already available, the database gets created.
Okay. Okay. So we don't have to manually create. DBA doesn't have to manually.
No, you don't have to create database like in that. That is the reason it is schemaless. Okay.
Okay. Okay.
Got it? See, Vijay, I can understand your anxiety, but you'll come to know step by step. Okay.
No,
if you want to see the course content, I'll give you one link at the end of the session. You can see all the detailed steps. Okay. Each and every day.
No, the reason why I'm asking is some of the features when you say about MongoDB, I'm not able to interrelate or I cannot really understand what exactly it is. Like if you can give a like what exactly it is and what has to be done so that I can, when you say the small features and all, I can easily interrelate and I can take it to my mind.
Okay.
That's the reason I asked you.
Yeah, I'll tell you. See. No, not a problem. You're always welcome to ask questions. See, what I'll tell is, see, this is a new database technology, right? So as a first initial level, you need to understand how to handle a single machine. Okay. First, you will be going through the installation part. Okay. Then we will come to know how to make the server up in a single machine. Okay. How to create database space. I mean, I mean, like where to have the backup files, where to have the log files, where to have the data files, all those things we'll see as part of the installation. Then we will come to know how to make the service up. Once the server is up and running, we can also decide on which port it is running. When we are trying to make the server up, you can decide on which port to run, like customized port you can use. And so, okay, now the server is up and running. Then the next thing is, you need to connect for sample data to create, or any at least sample database to create, and to insert some dummy data and to query it and see. We need to do some operations, right? So for that purpose, we need to connect it to server. So for connecting to server, what we need to do? We need to use a Mongo provided client tool, like SQL Plus for Oracle. What is available? Yeah, what is available in MongoDB we'll be seeing. We'll use that and we'll.
GUI mode or it's a graphical representation?
No, it's not graphical mode. It's like SQL Plus. It is a command based.
Command based.
Yeah, command based. Yeah, black screen command based tool. There are other third-party tools as well, GUI based tools like RoboMongo, which that also we'll cover in the course. Okay. And after that, what we will do is we will create some sample database. A sample database creation is nothing but the moment you use some database name and you enter the database, if it is not available, it will automatically create.
So you don't have to give the size of the database?
No, nothing. Okay. Again, your voice went low. Okay. Hello.
Yeah, I can hear you. Hello.
Yeah.
Hello. Yeah.
Yes. You don't have to specify size and all. Okay. Like this much number of size you need. You don't have to specify anything. That is what I am telling. It is very database administrator friendly.
Okay.
Okay. So then you need to say, for example, how to you want to create a collection, some sample table. You don't need to write any metadata here. You can directly start inserting into a collection. If it is not available, it creates automatically the collection.
Okay.
Okay. So that step is also over. The next step is what? We need to we already inserted it here. Then we will start seeing in normal relational databases what we'll do. We'll use command-based, like SQL server programming. We'll use queries. But here it's completely different. We need to give document-based queries. So we
document-based queries in the sense?
Document-based queries in the sense, like we need to, it's a special query language MongoDB provides. Okay, we'll see that part in the MongoDB course.
Okay.
I mean, like I'm telling the flow of complete course. Okay, in that
you were talking about like querying select staff from similar to that. There is a different
programming, yes, different query language, which is called object-oriented query language or document-based query language. We will see what are all operations we can perform by SQL query language. We will see how to do the similar things in MongoDB.
Okay.
Like
query language you told, no? That query language, whose responsibility to write that query language? For example, in Sybase or SQL, it's a developer's responsibility to write the query language. It's not DBS activity.
No. You have to know at least basic things like basic queries. You don't need, developers will be dealing with the programming part. If there is extensive programming in the application side, they will be doing. Okay, like you should understand like at least basic queries like reading query, writing query, updating, or how to perform AND logic, how to perform OR logic in operation, less than operation, greater than operation, updation, replacing an existing document, removing a document, removing a collection, or removing a database itself. You should understand all these concepts, right? You're getting right.
So for everything which you are saying, you have a query already, an inbuilt query for that.
Yes, right? Available. Those all things you'll be going through. Okay. That's all the programming language you will see. After that, we'll see how to create indexing, how to do query performance, how to improve the query performance. All those things we'll see. Then we will see like what after that. Import utilities. If you are having any data outside, we'll say in the flat files or JSON documents or CSV files, how to import them to MongoDB. And if you want to move data from MongoDB to some files, how to do import and export utilities you'll be seeing. And then we will see the backup strategies, how to take a backup, how to restore a backup. All those things will be coming.
Okay.
Okay. And then you will be seeing after backup completion, you will see how to set up a replication, and after that you will see how to set up a sharding. Okay.
What's that? Shadowing.
Sharding, auto sharding.
What is that?
Sharding is nothing but distributed environment, distributed scaling. Okay. Say for example, one table is there. You want to set a sharding on top of that. What you can do is you need to have a sharding architecture structure. You need to create for that. Say combining 3-4 replica sets. On top of that we'll create a sharding. So that collection, say for example 10 GB collection is there. It will be scattered into multiple small parts, and each and every shard location will have a part of that collection. Okay, in a distributed manner. Logically, for seeing it will appear as single place, but it will be distributed across the shard.
Okay, what is the purpose for that? Why is that we are doing sharding?
The whole purpose of MongoDB going is scaling, right? If you get terabytes of data per day, okay, you can't store it in one single machine, right?
Okay. Okay.
If you have everything in one single file or in a single server, it will take years for reading that terabytes of size. Okay, so that what we will do is we will scale into multiple servers.
Okay.
You got it? Vijay, see, we have to go bit by bit, Vijay. Okay. At this point of time, if you have, I appreciate that you questions, but like it will come to know over a period of time. Okay, you don't worry. All these things will come one by one. You when you are traveling across the course, you'll come to know. Okay, I stuck up in the fifth slide itself. Okay, don't worry. Okay, I'm just giving a gist what all things are available. Okay, got it?
Yeah, got it. Got it. Got it.
Okay. Then document based sixth point is like document based querying. Document based querying, as I said, like it's a query language given by that. Next thing is aggregation framework. Aggregation framework is also a kind of query language which for writing complex queries in MongoDB. Next, GridFS. GridFS is nothing but a grid file system like in normal relational databases like blob and all data types available, right? For storing big files. If you want to store a file itself in the database, we can go for this kind of data type, grid file system. And MongoDB management service is nothing but, in short, it is called MMS. I think I have already explained it, but I'll tell again. MongoDB management service is nothing but it's a diagnostic tool which will be installed in one of the in the LAN. We will install in one server, one MongoDB server. Okay. What it will do is it keeps pinging all the available Mongo servers in that network, and it reads its logs and sends it to the cloud, MongoDB cloud. MongoDB company itself freely provides you a login there. All this data will be pushed, and you can log into that prompt, and you can see how the help statement of your all MongoDB servers are.
Okay. Okay.
Okay, it's nothing but you can think like a monitoring portal.
Okay.
Okay. Next thing is partnership with MongoDB. They will give a support by going for enterprise edition like that. Okay. Then what MongoDB is not? MongoDB doesn't support SQL. Like we can't write SQL queries in MongoDB. Next thing is MongoDB doesn't support joins. Here we won't have any join operations in MongoDB. Okay. Why it is? Here we won't have small tables. Everything we will combine into single big tables, and we will have it in one table itself. All related tables, whatever we have, say for example, like in relational database, we will break it into multiple tables. But in the reverse, it happens here. We will have one big table where everything will have inside that database table itself. Okay. All related tables, to say in one word, say for example, a student information or say college information if we are handling, like college, we will start with a student, and student will have an address, and address will, and again he will also have a department. All those sub things like address. Address is nothing but that itself a complex object, right? Usually we'll have address as a separate table, but we will have that as a sub document, a document with another document. Like that we'll have, and we'll try to avoid having multiple tables. Okay, so that there is no need of joins in MongoDB. Next is, it is not a transactional based database. Okay, The purpose of going for MongoDB is we need to handle huge volume of data and with a very high speed of read and write capacity. So, like for example, social networking apps, mobile apps, gaming sites, or logging applications. These kind of applications will generally have MongoDB as a backend, where the amount of number of writes and reads will be very high. So database should not leave any request. It should not wait. No one should wait for the database. Everything should happen in a very faster manner. Okay. So those kind of applications we'll go for. It's not usually recommended for applications like banks and all. Their mission critical application is that we won't use MongoDB. Okay, and it not make sense for going using a MongoDB for banking kind of application, because a bank will always have a limited number of users and the transactions they do is always a limit, which can be very well handled by conventional databases, relational databases. Okay,
So it is not advisable for banks.
no, it is highly for where the amount of data coming is very huge. The traffic is very high. The amount of data per day will be very huge.
Even in banking environment also, it's huge only.
Now, I'll tell you a small example. See, for a bank, how many max the 10 lakh customers will be there?
Okay.
Okay, all 10 lakh customers, and again, it might have altogether say 10,000 employees, its own employees, bank employees. So, if you think altogether, how many people will come? 1,10,000 people. For 1,10,000 people, they won't be doing again transactions. Everyone at a one shot they won't do. Okay. Usually the max the transaction they do is they will go for ATMs and they'll draw the money. Okay. And other people will be going for the bank. So only the 10,000 employees, direct employees, will be interacting with the database directly. So the traffic for the database is very less here. The same thing if you relate it to Facebook application, let us assume, it will have billions of users, okay? Yeah. And everyone will try to write into the database at a time.
Yeah, correct. Yeah.
That is very huge. If you are not able to scale to receive that many number of writes, the application will crash or it will have very slow. User experience won't be good, but that's not happening. So that means these databases are special databases where it won't have constraints like transactions, acquiring the lock over the table, all those concepts is not there here. Okay, checking for the constraints before inserting data into the table, like whether it is a correct data or not, it has primary key or not, it has unique key and constraint or not. These kind of checks are not there. So that is the reason this is a very friendly database, which is good for applications like social networking, logging applications, or you need to log sensor data. These kind of applications is highly recommended. Okay. I can tell one more classic example. Say if there is one bank application or anything, if you are not able to, if you lose one record, also it's a very big problem in bank. But in the case of but if there is a slow in the application, that's not a problem. Okay, they will come back after some time and they can do their action. If the bank is slow, I mean the application is slow, it's not a problem. They can come back and after some time, or they can do that. But if the lose of data, say for example they do 1 lakh transaction and they send a fund transfer to someone, and if that transaction record is gone, that is a very big problem in a relational database where consistency is highly important than the performance. We can't use those databases for applications like Facebook. For example, 1 billion people are trying to give a like. Okay, if you lose one person like, that's not a problem. But at the same time, if you are not able to take, if you say, if I feel that I want that 1% out of 1 billion users is also very important for me. So I want to go for databases like Oracle. If I tell, then if I go for that at max 2,000 members or 20,000 members can connect at a time, and the rest of the people will have to wait for transaction to commit, and then till the lock gets released. You're getting right. You can relate the problem, right?
Yeah.
These are two different scenarios. The speed is important in case of applications like Facebook and all these things, and database should be able to scale very fastly without any downtime. But in the case of bank, safety is important, consistency is important than the performance, and the amount of load that comes is also very less there. Okay. Next. Yeah, usage areas, as I was telling, MongoDB is used as big data database and content management applications, customer data management, mobile apps, security and fraud apps, social and collaboration apps will be generally used. Currently, who are using MongoDB? These are some of the big multinational companies which are using Expedia, LinkedIn, Medtronic, SAP, MTV, Pearson, AT&T. All these companies are using in production right now MongoDB as their backend database. Then we'll see what is the comparison of the terminology to the relational databases. In a relational database, if we have a database, here also it is called database. A table in relational database is called collection here. Okay. A tuple or a row or a record in a relational database, here it is called a document. Okay. And columns, here it is called field or key. Okay. And joins, here there won't be joins, we will have embedded documents. Okay. So what embedded documents will be. And primary keys, here also primary key is available. That is a default primary key will be always created, and that is called _ID. Okay. MongoDB itself creates for every document an _ID value will be auto generated. Okay. And then indexing will be there. Here also indexing will be there. And MySQL D will be the server daemon. Oracle, the daemon name will be, server daemon names will be usually Oracle or MySQL, something like that. Here the server daemon name is MongoD. Okay. And similarly,
what is that actually daemon name?
Daemon means server instance name, server process name. Server process will be there, right?
Okay.
You got
in Oracle we call it as server daemon? Or?
No. Server daemon in the sense servers. What is main exe file which we use for making the server up?
Okay.
In Oracle it is called Oracle. Here it is called MongoD.
Okay.
Got it?
Okay.
MySQL in the client tools.
Got it.
Yeah, SQL plus. Here it is called Mongo.
Okay, got it.
Okay. JSON documents. Everything MongoDB stores, as I said, it is a document oriented. Okay. Then what type of data documents are these? Is a JSON documents. These are called. Okay. What this JSON document is? This is like again some plain text files which will have a extension as .json. Okay. These are similar like XML files. Like .xml files, these are also a special kind of files. Okay, it is easy for humans to read and write. We can also easily understand by seeing the document. We can easily understand what it is, and it is easy for machines to parse. And it is a text format. It will be available, and we can use as an alternate to XML documents. Usually for XMLs we will use for data transferring, right? between one machine to another machine. Similarly, .json files also used. And MongoDB uses these files for storing every record document. I mean, every record is called a document, right? That is nothing but each and every record is a JSON here, JSON documents.
Okay, it's like it's actually a MongoDB's this thing, correct?
Yes.
I mean.
No. I mean, in general also JSON files are there, like XML.
Okay.
JSON is a generalized concept, not related to Mongo. But Mongo stores its data in the format of JSONs, JSON documents. Okay.
Okay. So we can relate this JSON in Oracle as XML documents. Huh?
No. As a normal record.
Record. That's it. Okay.
Yeah, record is nothing but here a JSON document here.
Okay.
Its structure I'll show. See how it appears. First place, it is similar to like this. Okay, it starts with a flower brace, ends with a flower brace, and as I said, columns are here called keys. Here name, age, status, groups, all these are keys. And values are, it can be again different data types. Here this is a string, name, age is a number, this is a character, this is and groups, if you see, it's an array. Okay. A value can be again of different types. Okay. This is a sample document. Okay. In MongoDB it stores like this.
Okay.
Each and every record will be available as a document in this format. Basically, JSON files will look like this. Got it?
So you have a particular query to retrieve this.
Yes, we need to write a document-based query. We will see how it appears and everything. Okay? In the next classes. Here you can see, right? This is the JSON syntax. For example, this diagram explains like it starts with a flower brace, ends with a flower brace, and all keys are comma separated. Okay, key colon value, key value pairs, these are called, and each and every key value pair is comma separated. Like that, it can have any number of key values within a document. Within a document in the sense within the flower braces. Okay, and key is always a string. Okay, and value can be, it can be a string or it can be a number, it can be an object. Here object is nothing but another document, a document within another document. Okay, or a value can also be an array. Array means it starts with square brace, ends with square brace. It can also be a boolean like true, false, like that. It can also be a null value. Okay. Now can you write? We'll see another JSON example. Okay, for a college application. See here, this is one document. Whatever you are seeing is another document. Okay. Here college is a key, and its value is this one, XYZ college, and department is another key, strength is another key, employees is another key, whose value is actually an array. Because it starts with square brace and ends with square brace. It's called an array. What the array contains is, again, two documents are there internally. These two documents are called embedded documents. Because it's there, already one document is there. Inside that document, the second documents are there, sub-documents are there, right? Okay. So these are called sub-documents. Hello?
Yeah, okay.
Got it, right?
Yeah, got it.
This is how the document structures inside the MongoDB it will be. Okay, if you want to insert any data also, you have to insert in this fashion only, document. Okay. Got it, right? That is the difference, like compared to others. Okay. Yes. Say for example, here actually employees, if you do the same design in relational, these employees will have as a separate table, which will have first name and last name, and we'll have a primary key to the this actual college table. But here, if you see, everything we are having in the single document. That avoids the concept of joins. Okay. Any doubt?
Because the developing part and all, I was not taking care of that actually. So this is
No, no, no. No, at this point of time, you can't tell like that. This is initial new technology. You can't have the similar roles and responsibility what you are doing in regular maintenance or support activities. You can't expect like that. People expect like you to have a overall knowledge.
Yeah, that's true.
Okay.
No, you asked
You
my
have to.
doubts, no? So I I really don't have any doubt on this because I don't have an exposure on this.
No,
Development.
this is not development related. You like how you say, for example, if someone asks you to insert a document into a database, can't you insert single document? You know, right?
Yeah.
Then you should know obviously. Yeah, you have to know. That's the part of database role. Database administration should have a basic idea of how data gets inserted. Yeah, what you said is correct. Usually we won't be inserting data into backend. We'll be just checking with the DB activities, but
Yeah.
but we should know how to insert data.
Got it.
Got it? And how the structure appears. Obviously, unless until you know the structure how it stores, you can't query because the query language completely depends on this structure how it stores. Okay. And the data types, as I said, it can be a null or it can be a number. Here, data type in the sense value, key value, right? Value can be a null, a number, string, object. Object is nothing but a document, subdocument, array, and a binary data. It can be object ID, boolean. It can be a date, timestamp, or it can be a regular expression or anything. Okay. In the next day session, we will see installation and all.
Okay, fine. Okay. And if you could kindly send me this contents, what are the things we are going to learn?
Yeah, I'll send my website link. Okay, it will have actually the full course, the flow also you can see, and I'll send this slide, day one slide. I'll send the recording link. I'll also send a complete course Word document is there.
Okay.
It's available in Word document format. I'll give that as well. Okay.
Okay, fine. Okay. I mean, you're going to send it to my mail?
Yeah, I'll send it to both of you.
Both of mail. Okay.
Yeah, I'll send it in Gmail. Okay.
Okay.
From Gmail, I'll send. Okay. You're clear, right?
Yeah, I'm very much clear. No issues.
Okay.
Yeah.
Okay. Don't worry about all the things at one shot. Okay. We'll be going one by one. Okay.
Okay.
Everything you'll come to know. Don't worry. Initially, a bit this terminology and all will be new. Okay. Before coming to next class, just whatever we have gone through. If you have doubts, go through the video again, see the slides, and come to the next session. Okay. Whatever you have doubts, we can discuss it in the next class. Okay. Tomorrow, be sharp at 5. Okay.
Okay, fine.
Just tell the Kavita as well.
Okay.
Okay, Vijay.
Yeah, fine. Thank you so much.
Thank you. Bye.
Yeah. Okay, bye. Okay, bye.